Factoring quadratic expressions, part 2. What I'm going to do first is go over an example of how to factor a quadratic expression when we have our a equal to 1. So, what do I mean by a? Remember, this is the value in front of your x squared term is your a, this is your b, and of course this is our c. So right now we're dealing with the coefficient of the x squared term is 1. So I'm going to use the x method to factor, and in doing so I'm going to set up the b and c. So b goes up here and the c goes down here. The value of b is a positive 11 and the value of c is the positive 28. So I'm looking for what could my two factors be that if I add these two numbers, they'll give us 11, and if I multiply them, they'll give us 28. So, in doing so, we need to find the factors of 28. And so we have 1 and 28, always start with the smallest, 2 and 14, 4 and 7, and then of course they repeat 7 and 4, so I'm not interested in repeating them. Out of our pairs, which one of them comes close to giving us the 11? Well, 7 and 4 definitely give us the 11. So we're going to need 7 and 4, 4 and 7. It really doesn't matter in which order. So we're looking for a positive 11. That means these two numbers have to be positive. And if those two numbers multiply, they give us the positive 28. So everything's good. Our final answer, of course, is two binomials in which x is in both binomials. This one will be a plus 7 and this one will be a plus 4. So this is how we factored quadratic expressions when a was 1. So for today's lesson, something you need to know or be familiar with is GCF. You're probably wondering, okay, what's GCF? And it's the greatest common factor. So what that is, okay, so we have an 8. Factors of 8 are 1 and 8, 2 and 4. Factors of 12, we have 1 and 12, 2 and 6, 3 and 4. So between these two numbers, we are looking for the largest number that they have in common, basically. So the greatest common factor. As you can see, they have a 2 in common, they have a 1 in common, but they also have a 4 in common. So the largest number in this case is a 4, so therefore the GCF is 4. Okay, so something easy. Now, what if this 8 was 8x cubed and this 12 was 12x to the 5th? Then what would be the GCF? Okay, well, we know between 8 and 12, 4 is the largest number. But now looking at the variables, okay, think about it as candy. What would be a fair amount of candy to take out between these two? So we can't take 5 out because this guy here doesn't even have 5 of them. What it does have is 3. So you could take 3 away from that, and we can afford to take 3 away from that. So then our GCF would be 4x cubed from these two terms here. So that's the idea for today's lesson, what we're going to add on for factoring. Okay, so moving on to the next example, factor each polynomial expression by first finding the GCF. So here we have a quadratic expression. How do we know it's quadratic? Because the highest degree is a 2. So looking at these three terms here, you want to look at them carefully and think, okay, I got a factor. But is there anything these numbers have in common? We have a 3, and a 36. So what you want to think is, okay, can everything be divisible by 3? And the answer is yes. All of these terms can be divisible by 3. So what we're going to do is we're going to take out that 3 that they have in common. This is called factoring. We're taking out what they have in common, and inside the parentheses is what's remaining after you take out what they have in common. So this is like the opposite of distribution. So if I took out a 3, that means I divided by 3. 3 divided by 3 is 1. X squared remains as x squared. And of course there's a 1 here, but we don't need it. Next one, we factored out a 3. We took out a 3. 3 divided by 3 is 1. X, well, the x comes down, and again there's a 1 here, but we don't need it. Negative 36 divided by 3. We can factor out a 3 because that's what these have in common. And we are left with minus 12. So, looking at what's inside the parentheses only, can we factor? Can we do what I did earlier with the x method and all that? So again, only looking at the trinomial, the quadratic that is inside the parentheses. So my b goes up here, my c goes down here. My b is a positive 1, my c is a minus 12. I'm looking for the factors of 12, 1 and 12, 2 and 6, 3 and 4, that these factors are going to give us a 1, where the only ones that can give us a 1 are the 3 and the 4. So we're going to use 3 and 4. The only way these two numbers are going to give us a 4 is if one is positive and the other one is negative. Okay, so in our final answer, for sure we have to have x and x in both binomials. One of them is going to have a minus 3, the other is going to have a plus 4. But let's not forget about that 3 that we factored out in the very beginning of this problem. And now we have gotten our factored form. That's as much as we can factor. So let's try another one. Factor each polynomial expression as much as possible. Okay, so several things here. We want to look at the coefficients, and we want to think, is there a GCF? What's the largest number out of these 3 that we can factor out? And of course, it's kind of obvious. Everything's divisible by 2. So that means I'm going to divide everything by 2. I'm going to factor out a 2. But if you also pay attention to what's happening here, we have x cubed, x squared, x. They all have an x. So what would be the smallest amount of x's that we could take away from each one? So this one has 3, this one has 2, this one has 1. So to be fair, the smallest amount that we could take out from each of them is 1 single x. Okay. So that means I'm also going to factor out an x. So I'm taking out a 2x, I'm factoring out, and what we have remaining is 2 divided by 2, because I'm factoring out a 2, is 1, but we don't need it. X cubed divided by x, we're taking out an x, we're subtracting an x, so we're left with x squared. Negative 48 divided by 2. X squared divided by x, it's like subtracting an x, so you're left with 1x. And then we have 40 divided by 2, that is a positive 20. X divided by x, that reduces to 1. So that's what we have. Okay. Got to keep factoring. So now we're going to look at what's inside of the parentheses. We're going to set up the x. And we're going to look for factors of 20 that can combine us to give us 24 and multiply to give us 20. Okay, so let's see. Factors of 20, we need to do our table, our factor table. So 1 and 20, 2 and 10, 4 and 5, and that's it. So somehow these factors have to give us a 24. Okay, well, it seems like the highest we can do is 1 and 20, but 1 and 20 will never give us a 24. So it seems like we cannot factor anymore. So this is as far as we can go. And that's it. That's our factored answer. Next one. Here we have x cubed plus 3x squared minus 40x. So if we look at the coefficients, this has a 1, this has a 3, this has a 40. They have nothing in common. However, each term has an x involved. So that means we can factor out an x. You can take out an x from each term. So this, again, this is like the opposite of distributing. Or actually, this is exactly the opposite of distributing. So we're taking out an x from here, from here, from here. X cubed divided by x, x squared. 3 stays the same. X squared divided by x is x. Negative 40. X divided by x is 1. Okay. So next we're going to look at what's inside of the parentheses at that quadratic, and we're going to continue to factor. See if we can. So we are looking for the factors of 40. So we need to do our factor table. So I'm going to do it over here. We start off with the smallest one, 1 and 40, 2 and 20, 4 and 10, 5 and 8, then it's 8 and 5, and they all start to repeat. So we're looking for the combination of two numbers that can give us a 3. And well, 5 and 8 are going to give us a 3. The only way 5 and 8 can give us a 3 is if one is positive and the other one is negative. So the 8 would have to be positive to give us a positive 3. Therefore, our final answer will be, for sure we need two parentheses. X goes in both. We need a minus 5 and we need a plus 8. But don't forget that in the very beginning, we factored out an x. So this will be our final answer. Next example. If you notice, look at it carefully, it looks different. Why? Because this is a binomial expression. All the other ones have been trinomials. So let's see how this is going to work out. What we're going to do first is we're going to look at the problem and think, okay, GCF, is there anything that I can factor out from these here? Okay, so this is a 3, this is a 6. They're both divisible by 3. So for sure, we can factor out a 3. But is that the only thing that you can take out of these two? And the answer is no. We can also take out an x. This has 2 x's, this has 1. So to be fair, we can take out a single x. So that means we divided each of these by 3x. Again, this is the opposite of distributing. So instead of multiplying, we're going to divide. We're going to take out. 3 divided by 3 is 1. X squared divided by x is just x with a 1 in front, but we don't need it. Negative 6 divided by 3 is negative 2. X divided by x is just 1. Reduces to 1. So this is our factored answer. This is as far as we go. Nothing else we can do in this problem. So that was pretty easy. Next one. Here, if you pay close attention, once again, you're going to notice that, first of all, it's not written in standard form. So the first thing you got to do is rewrite it so it is in standard form. Okay. Next, we're going to look at each coefficient, each number here. Now, these are really large numbers, so we got to think, okay, what's the GCF between 16, 48, and 80? The first thing to do is think, okay, could all of these numbers be divisible by 16? And the answer is yes, they can all be divisible by 16. So we're going to factor out a 16. What else? Is there anything else we can take out? Do they all have x's? This has an X, this has an X, this one doesn't. Nope, not all of them have it. What all of them do have is a negative sign. So not only are we going to factor out a 16, we're going to factor out a negative 16. So that means that every single one of these is going to be divided by negative 16. So when we divide, the result will be negative 16 divided by negative 16 is positive 1. So 1x squared. Again, we don't need the 1. Negative 48 divided by negative 16 is a positive 3x. And negative 80 divided by 16 is a positive 5. So looking at this here only, what's inside, we're going to create our x. Okay, b goes on top, c goes in the bottom, so this is 3 and 5. We're looking for the factors of 5, 1 and 5, that can give us a 3. Well, we're stuck in a situation, in a problem here, where only 1 and 5 are the factors. These cannot give us a 3, so this is as far as we go when it comes to factoring. That's it. We were only able to take out a negative 16. We cannot do anything else with what's inside of the parentheses. So that's our final answer. And that's it.